Hey there, myself Krish Shatakar, very warm welcome to all. And in this day, we actually focus on system design concepts like acid and solid principle. This is both principles are very important on perspective when we're looking toward software design. And this particular both topic are dedicated toward the low level design, and you should to know about it. Because of that, we should to just figure it out the first how this particular one is important and what the basic sets of rule are. And that's important to discuss for today. And again, if this one is going to productive for you, we learn something from there, then it's my pleasure. Let's start. Let's come to the first agenda, and in this agenda we actually focus on acid principle, and that's the necessary one. Because of that, when we're talking about payments apps and lots of software which is based on dedicated on this particular principle, because of that's important. Because why this particular acid principle is necessary, and that's only reason I think on to maintaining the structure of the code. And I think for the particular security and reliability and resilience, all this particular stuff, for maintaining that particular stuff we need that kind of principles. Okay, so acid principle is important from on that particular purpose. So let's come to this first. What is acid? Acid refer to acid stand for A for atomicity, okay, and C for consistency, I for isolation, and D for durability. Okay, so let's start a little try to understand this particular one, how it's actually work. So when we actually talking about atomicity, atomicity refer to you understand in such way if either all or nothing. Let's suppose if you want to send a money to one person to another person, the the like you suppose you are uh, person A and second one is person B, and the person B demanded money for 20 rupees. Okay, so in that particular transaction between both and you and person A and person B, I think in that transaction the only possible things, I think what's a strict rule is like atomicity. Let's suppose atomicity work here is like something, you send either 20 rupees total or nothing. Okay, so let's try to explain you. When actually you using a GPay or and the phone pay and anything else, you if you want to just use this particular stuff, you transfer money. But sometime even you notice the money will be transferred, half of the money transferred, half is left behind. That never happen inside. Like now suppose if you transfer, if you send the money 50 rupees, then your 50 rupees transfer it to your bank account, particular bank account that you are targeted. Not at six, it's like 7 rupees are transferred and 6 rupees are left behind. It's not happen. Because of that, atomicity says that consistency, atomicity says that either all or not. Okay, so you transfer all the money or not. If it failed, then entire transaction failed, half of money will transfer it, and that's not happen. Okay, so that's the basic atomicity is. Second is consistency. Consistency refer to something, you can say, when we actually want to just update the both numbers. We actually When we actually talk about GPay and online payments app, all the particular apps are basically mad of one of the basic principle like consistency. We need to update the all the numbers. We actually play with the numbers, not that real money is transferred between the or like okay, we actually play with the numbers. Okay, so in that part, the all the numbers are transferred between the one person to another person. Then we need to update the number inconsistently without any just losing any information. So now suppose if you send the money to 2 rupees, let's suppose this is the balance of the user 2, 30 rupees, and user B 20 rupees. Okay, we need to when this user 2 send money to user 1, then we need to reduce this particular money at 30 minus 2 to this particular portion, and we need to add this particular one is 2 consistently without any just says waiting for that particular time. So After transaction happen, we deduct and we add, so that the particular debit and credit according to it. So that's the consistency. We need to balance the both accounts numbers consistently without any excuses. Okay, so second thing, like isolation. Isolation is like decouple process. Isolation is like, let's suppose like lots of the payments happen between you and your partner. Okay, what happened in that isolation says that, like in that all the payment happen in your you and between your partner. I think like there were no any I think like there were no any just uh like interruption of one and another payments. Let me try to explain you. Let this is the payment one at some certain time. The payment two, payment one, payment two, payment three. Lots of payment happen between you and your partner. Okay, and in that particular one, payment one not interrupt payment two. Payment two, this all the particular payments independently happen in decouple process. They are independently happen. Okay, they are not dependent from each other. If the one fail other fail, it's not okay. So that's the basic thing isolation want to say. The all the particular payments, all the particular process kept in your mind, keep in your particular technical system as isolated. They are not dependent from each other. Okay, and second one is durability. If the one particular one is committed, then its particular thing is committed. Okay, now suppose if you send an email, then I think you send email that particular and user A send email and user B received, then I think like this one is committed. You can't remove this particular one at from the other portion memories, and from your side they actually get that particular email. So that the basic thing that I think like ACID property want to say. ACID property is important because of the main reason is behind the scene we should to know about ACID property is all about ACID is necessary because of that. When we actually focus on that, making lots of enterprise application and payment gateway app, and lots more important app, which is really if you want to just make payments, payment gateway app, and lots of things like. Okay, so we need ACID principle, and this particular thing actually maintain your structure of the code and maintain resilience, maintain redundancy, and reliability, all the particular stuff that you think. So, okay, and for making your software much better work, okay, and for maintaining security, if you just you need to focus on the ACID principle. So that's why I think like ACID principle is important for us. So, okay, thanks. Let's move to agenda number two. Let's come to the agenda number two, and in this agenda we actually focus on the solid principle, and that is the important part because of that when we actually design a particular software. So we need that kind of the solid principle because of that this particular one maintain our structure of the code, and maintain reliability of the code, and help us to keep maintain code for long term uses. That's important. Okay, so let's start with the solid principle. I think like this is important. Solid principle is stand for SOLID. Okay, SOLID: single responsibility, open close, scope substitution, interface segregation principle, and DTP, dependency inversion principle. So I will try to connect all the particular words and explain you that what the context behind the scene. So let's come to the first, single responsibility. When we actually talking about single responsibility, it's all about like when we try to make a particular application. Okay, we have a we actually deals with the object and classes. If you don't know what's the object and classes, I will try to connect you this, explain you. Like let's suppose you want to write a code. Okay, so entire write code of entire code logic, we make one parents class and one child class, parents and child. Okay, so if I want to say that what the single responsibility is, we divide the entire code logic in parents and class. Let's suppose class. So in that particular class, we keep all the particular class logic at dedicated toward the one single responsibility. Let's suppose I written 5 line of the code in class. Okay, if I write 5 lines of the code in a class, then I think like in that particular one, this particular class dedicated toward the one single responsibility. That's make our particular code more structured and more understandable if in for future, if you don't just know what the basic code is. For understanding purpose, this is important. So that's the single responsibilities want to say one particular class, one particular object, any you want to say is dedicated to one single responsibility, not at multiple. Okay, so that's maintain our structure of the code. Second, open and close. So it's all about like class and object are basically when we actually try to make a class in the particular code, then I think like it open for extension and close for modification. How what exactly I will try to explain you. Let's suppose you write a code which actually calculate the numbers between 1 and 100. Okay, if you got any error and anything else, any bug in that particular class, okay, I think you need to extend this particular code. You are not going to just modify this code. So that's the particular one open for extension. You add the new class where you explain that logic first and just mute this particular logic you uh, done previously. You are not going to modify this particular one by removing anything else. So that's the basic thing talking about open and close. Second one is like scope substitution. This is very necessary one, and I think like scope substitution is work like something. Let's suppose this is a base class, subclass. So base class is considered base class as universal set where acquire the all the particular information, all the particular behavior. Let's suppose base class is animal. Okay, so I write a code. I say write the name of all the animals. So that's animal is our base class. This is a universal set where the all the particular name of animal, if I just add, then it's dedicated toward the base class. Base class animal, we can in that subclass, if I subclass is all about subtypes, it's under. So it is base class define the particular behavior of the entire structure. It's universal structure, and base class and subclass is a cat. Cat is something you can say cat is animal. So if it when we're talking about base class, so we can keep this sub class as a base. So base class and subclass merge because of that. When we're talking about name the all the animals, the cat is animal. What happened with car? Car is not an animal. So car is not a part of the base class. So that's the particular one to say when you actually write a code, you have lots of things like the first is base class and second one is subclass. You need to just mention this both behavior of the both class are need to same. Okay, so that's the basic thing that we are talking about. So the behavior of both classes need to same when you're talking about write the name of animal, and when you write a logic behind this particular base class, then you should to be careful that the logic and behavior should to same. They not create unexpected behavior that you don't want deserve. So I think scope substitution ensure that trust, consistency, trust and consistency. For example, trust says that like we need to just both base and class behave same. Okay, and consistently say that they're not just as different from each other, they actually use the same kinds of the parameters. Okay, so that's the basic thing. Okay, that's the scope substitution. And ISP, interface segregation principle, says that like now suppose if you want to design interface, payment gateway app, anything, how much the control that you want to give to a particular user. You just not uh, trap the user on some unnecessary task. So you want to design UI, so you need to just separate out this particular interface segregate this particular. So that's the ISP, interface segregation principle, which says that we need to just separate out this all the particular stuff what the particular user get. We not just keep the user for unnecessary interface. Okay, so that's the basic thing that we're talking about. And DTP, like dependency inversion principle, it says like all the particular process happen inside this particular software are decoupled. They are not dependent from each other. They are not interdependent from each other. So if the one fail, other will continue. So that's the basic thing that we are talking about, and that the solid principle is, and why actually solid principle is important. Again, for maintaining structure of code, if you want to just maintain your particular code, if you want to just build $1 billion of app, that principle is very important. And especially in vibe coding also, people focus on that lots of the coding methods, but they don't care about the basic thing inside this. And why this particular happen inside this particular, because of they do vibe code, and I think like they have a no any command over the entire code logic. The AI agents look all this particular stuff and don't know, they apply all the high dimensional logics. But when you actually learn this particular solid principle, I think like this is important when we actually try to do particular stuff. Okay, so that's the important part. So again, if this one is going to productive for you, if you learn something from there, then it's my pleasure. See you soon.